Hi, I'm Neil Hermes and welcome to my weekly bird wrap, brought to you this week from Jerrabomberra Wetlands. I've got three great stories for you this week. One is about how birds fly. Now we all know the birds fly, but research on how they actually do it and what matters. A story about malleefowl and another one about how birds are getting smaller as temperature increases. Hi, I'm Neil Hermes and welcome to my weekly bird wrap. My first story this week is about how birds fly. Now you might say, well, we know how birds fly. They flap their wings and off they go, and you know, it's all known. Well, as it turns out, we don't know the technical ways in which the structure of a bird determines how it actually flies. And there's been some really interesting research just done in the last year looking at the shape of the sternum. Now, if you've ever eaten a roast chicken, the sternum is that big pointy bone that has the fleshy parts on either side. It has a bit of a dip in it. And in a chicken, it's a sort of raised section like that and a flattened part on the bottom. And of course, this is the part that's at the front of the bird. And this is a part where the muscles that are attached to the wing are attached to the body. Now, the shape of the sternum, as it turns out, has a huge impact on the way a bird can fly. If the sternum is shallow, i.e. that big ridge piece that you have in a chicken is not very high, it makes the bird less likely to be a heavy flapping bird. If the sternum is long, it determines whether or not birds can run well or not. So the length of the sternum and the shape of the sternum is a powerful indicator of how a bird actually flies. Now this is interesting from a range of points of view. If we understand more about these sorts of things, this can often have a practical use for us when we're designing various sorts of machines. It also means when we find fossils of fossil birds or fossil dinosaurs, we can interpret the behavioural patterns of those animals by looking at the shape of the sternum. So there you go, there's something we've learnt about how birds fly by looking at the bone in the chest bone of a sample of about 100 different species of birds. My second story today is about malleefowl. Now, malleefowl are an Australian bird that are found in the inland parts of southern Australia. They're largely confined to areas of mallee, and mallee is a type of eucalyptus that grows with multiple stems from the ground. In the past, these habitats were very common through South Australia, Victoria, New South Wales and into Queensland. But sadly for the malleefowl, these areas have also been fabulous areas for wheat growing. So since the 1900s, a lot of these areas have been cleared and malleefowl have been reduced down to smaller and smaller areas. Malleefowl are about the size of a big turkey and they stalk about on the ground. They don't fly very well. They can sort of limber up onto trees, but they don't fly well. They're a very heavy bird, and they're well known for digging a mound, burying their eggs in the mound, covering it, and essentially using the mound as a compost heap to raise their chicks. They don't incubate the young. The male comes to the mound every day, digs it out, checks the temperature, and then recovers it with enough mound material to maintain the temperature for the eggs. Now, these birds have got rarer and rarer, and there are some projects now starting in Australia where we've fenced off some of the reserves where these birds used to occur in numbers. It would appear that not only is it clearing the habitat, but things like pigs and foxes have been a problem. And there's groups now raising the chicks from eggs in artificial environments and then releasing the young chicks, which never know their parents. When they come up out of these mounds, they're like a chicken. They just run off into the well, unlike a chicken that stays with its parent, what I mean by chicken is that when they emerge, they can run about and they can be relatively independent. And malleefowl are completely independent. Within an hour or so of leaving the mound, they're off. And they do get taken by foxes and pigs. So there's these projects now throughout southern Australia where we're reintroducing malleefowl young into areas where controls have been put on the foxes and pigs to try and increase the numbers again in some of these fabulous malleefowl areas of southern Australia. My last story today is about how, as temperatures rise, the body size of birds decreases. Now, this is a well-known phenomena. There's a law, in fact, that was created back in the 1800s when Bergman, a German scientist, observed that species of birds or mammals that occurred close to the equator were relatively small, and their very close relatives that occurred closer to the poles were much larger. So this is a natural phenomenon in terms of a species of animal responding to the temperature. Look at a species like the tiger, for example. The largest tigers are the ones that occur in Siberia. The smallest tigers are the ones that occur in India. The same pattern with penguins. In penguins, the smallest ones occur in the Galapagos, the largest ones occur in the Antarctic. This pattern of size related to temperature is and has been well known for a long time. What we're now finding, as the Earth's climate warms up by a number of degrees, some species of birds are now also decreasing in size. Now, this is something that is probably to be expected, but this piece of research also found out another very fascinating extra piece of information to this puzzle. Not only are the birds getting a little bit smaller, the ones with bigger brains got smaller more slowly. So a bigger brain gives you the ability not to have to reduce your size. So different species of birds are proportionally getting smaller with temperature, depending on their brain size. Now, this is a really unusual discovery and has all sorts of implications. Species like song sparrows, house sparrows have a particularly large brain size for their body. And so we'll have different patterns of changes of bird populations as temperatures change, depending not only just on the temperature, but other factors about birds which we are yet to really fully understand. So that's an interesting piece of research that's no doubt going to go along for a long time yet for us to really unravel that story. And I hope you've enjoyed the 3 stories I've had for you this week, bringing them to you from Jerrabomberra Wetlands here in the ACT. If you're interested in this story, check out my other stories on my website, have a look at my YouTube channel, and get out there and do a bit of bird watching, and happy bird watching.